Welcome to Virtualization SAP Workloads with SUSE KVM tutorial. My name is Gerion Fay. I'm on the SAP campus for 25 years now. Joined SUSE 4 years ago. And my first thing to do was a validation of SAP HANA on SUSE KVM. Brought with me Arne Wolf, my colleague, who is doing the really heavy lifting nowadays. So let's get started. I first want to quickly talk about virtualization in general and then go over the supported scenarios as of today. And then Arne will cover a few insights on how difficult this stuff is and also share the roadmap and the outlook. And after that, we will have a lot of time, I hope, for Q&A. The event ends on Wednesday. Until then, you can ask your questions. So, SAP virtualization. Why would somebody do that? Well, it's pretty easy. Hardware virtualization is increasing the utilization usually. And with that comes a few other perks like that you need less power, less cooling, less rack space. However, the most important aspect, I think, is the simplified management and the agility you gain, and with that the productivity. So virtualization is a standard nowadays in data centers. So it's not really the question of why would you do that, but how. And this is what we want to talk about today. So in the SAP context, SAP is always special. They really want to make sure that their customers run their software in a well-defined environment. And this is really a good thing, because usually the SAP software is running the business. If the SAP software goes down for whatever reason or gets corrupted, the business is in trouble. So part of the validation is always to ensure that the integrity of the data is okay, that you don't lose data even if things go down. And also, in case there's troubles, that SAP and we as their partner can help the customer. So for that, data is needed, like, for example, from within the VM insights into the hypervisor, a joint support process, and other things. And in the case of SAP HANA, there's also one very important aspect: performance. SAP promises kind of a certain level of performance with SAP HANA, so that's why performance is also part of the validation. And you notice I speak about validation and not certification. And in the SAP context, again, this has a special meaning. A certification in the SAP context is something that the SAP Integration Certification Center, or short ICC, performs. And these are fixed scenarios where they do those certifications with specific test plans. And the partner performs those tests, and they are supervised by the ICC. And then in the end, it gets you as a partner a nice certificate and a listing on our website. So really good for marketing purposes. A validation is done by the SAP Product Management Organization or the SAP Development Organization together with the partner. We do tests together to ensure that the performance is right and the function is right, and and really see what's needed to be supportable. And as you can already tell, this is a joint effort between the partner and SAP. After a successful validation, SAP puts a support statement in an SAP node, like a knowledge base article, but it's a really strong document. And then you have a joint support for the validated solution. That's the difference between a certification and a validation. The hypervisor validation is a validation. So what are the options if you want to virtualize SAP systems? Obviously, and this has been the most used hypervisor, I guess, VMware vSphere and ESXi. They have been the clear leader in the game and have the broadest coverage. I mean, basically the whole company is about virtualization, so that's not really surprising. Then there's Nutanix with a HAV hypervisor. They have a pretty broad coverage as well. They have special hardware for this, so you can't just take any hardware. It's HCI, so hyperconverged infrastructure hardware. And there's a limited VM size because of that. I have footnotes here, so I don't want to read out the SAP notes, but if you're interested, they are on the screen. Then one of the other options would be Red Hat OpenShift Virtualization. This is, as of today, not supported by SAP. There's an SAP note saying that SAP doesn't intend to support it. The other product which has been validated for SAP and SAP HANA workloads is Red Hat Virtualization. That's at the end of its life cycle. So general support has already ended. Maintenance support ends in August this year. So draw your conclusions from that. Obviously, just like we do, Red Hat have KVM in their RHEL, in the Red Hat Enterprise Linux, but this hasn't been validated for SAP HANA as a hypervisor. So that's not an option either. We as SUSE have KVM in SUSE Linux Enterprise Server for SAP applications and the plain SUSE Linux Enterprise Server. And both SAP HANA and non-HANA SAP workloads are validated. So let's get into a little bit of detail here. There are two sets of validations, basically. One is SAP applications, all the NetWeaver stuff, like S/4HANA, but without the HANA part. And so all the application server things are supported for production on SLES for SAP and SLES since like forever. So there are SAP notes with a general support statement. I really recommend you to read this. This is 1492000. This is where everything starts if you want to look up the hypervisor validations. It has pointers to all the other SAP notes mentioned here. So this is really one that you should remember. I will ask at the end. And this talks about the SAP application servers and also on the non-SAP databases, or I should say the non-HANA databases. So IBM DB2, SAP ASE are generally supported for production. Oracle decided not to support it. SAP HANA has more restricted validation requirements. We will talk about that later. I didn't list SQL Server here for pretty obvious reasons. But yeah, that's not in there either. But if it's not HANA, you can run your SAP system virtualized on SUSE KVM with DB2 or with ASE. No problem. Virtualizing SAP HANA with SUSE KVM. As I mentioned, SAP HANA is special because of the performance requirements. We have pretty strict KPIs to fulfill here. I think Arne will talk about that later. We have been doing validations for HANA for quite a while. For non-production, no problem. You can just use your // or /SAP applications. For production, there are very specific versions which are validated as a hypervisor for VMs containing SAP HANA as a workload. So, and this is tied to a number of things. As you can see here, we have the versions of SLES. We have the hardware platform and a few things. So really take this as a reference. And we do intend to extend this list. The validation of a hypervisor for SAP HANA is pretty darn complicated, not only from the technical perspective, but also on what are we really validating here. So we are validating a specific hypervisor version. For SUSE Linux Enterprise Server, that means a specific SP version, because that's what defines the version of the kernel, of QEMU, of libvirt, and they change with every SP. So this is one dimension in the multi-dimensional table of support possibilities. The next one is the hardware architecture. So not only is it a specific service pack, but it's a specific service pack on a specific hardware platform. And we are not talking about Power versus x86 or something like that. We are talking about the CPU families. So Skylake or Cascade Lake. Forgive me if I don't remember all the marketing names for the Intel CPUs. Intel Xeon SP generation 4. I don't know. That would be Sapphire Rapids. Also, there are limits for the number of CPUs or sockets in the system. That's another dimension in the table. That's an up to. Also, the amount of memory is limited in a certain configuration. Then we have to validate storage types, be it fiber channel storage, be it network attached storage like NFS, be it direct attached storage like local drives or a expansion box that's connected to your RAID controller. So that's something. And then there are these nice virtualization scenarios which SAP defined. There's a single VM, so one VM on a virtualization host. Multi-VM means multiple VMs on a virtualization host. That's what you normally do. Live migration is a special scenario. VMHA, so high availability on the VM level. meaning if one host fails, the VM is moved to another host. Scale up and scale out. So there are super many dimensions to this, and it makes it really complicated and really a lot of effort to validate a hypervisor for SAP HANA. So this is really complicated stuff, and I don't really want to do this again, so Arne is doing it now.
Hello.
So, Arne, your turn.
Thank you very much. Carry on. A short introduction. My name is Arne Wolf. I'm a solution architect.
I'm not sure your mic is on. Is
Pardon?
your mic on? Is your microphone?
You can hear me, right? Yeah, okay.
Good.
I'm a solution architect in Garion's team. As you can imagine, mainly my main purpose is to get this HANA on KVM validation through every year, or shorter. The first topic I will be covering is achieving optimal performance inside a virtual machine, and then I'll talk a little about the current validations that have been done already and the outlook, what is going to happen in the next couple of months, I hope. What's the big deal? Or, in other words, why are we bothering? Well, the goal is obviously always customer satisfaction. I'll get into that now, why this is the basis for customer satisfaction. If a customer, probably some are here, want to evaluate a decision being made to or away from virtualization, it's always very important to you probably to know what is the performance impact when moving from bare metal to a virtualized environment, and to predict the risks at some point. So, like, do I have to account for more maintenance cycles, or do I? How is the support covered when I add an abstraction layer to my current environment? Things like that. That's the main reason, I believe, why SAP has established that hypervisor validation. That hypervisor validation is always a comparison to bare metal. So there are at least 3 out of the 4 bigger benchmarks that we do. It's never against absolute values. It's always the comparison between the bare metal system and the virtual machine running on the exact same system, just in a hypervisor. In addition to that, this is very important for us to, well, put it in other words, one benefit we get out of this is through those validations, we put the system under a very specific stress that you usually only see if you're working in such a high performance environment like on SAP HANA systems. So we know the systems before they get out in the field, before the customer has to use it, and we sometimes even discovered some bugs before the customer found them. That's good for us, that's good for the customer. And last but not least, we create a very specific environment while we are doing the validations, and give a customer or a partner or whoever else will want to use it everything they need to create a validation-like scenario inside their own data center. And in the best case, we are transporting near bare metal performance through the abstraction layer. Yeah, that's about it. The scope of the SAP HANA Hypervisor validation is basically what you read here. It's 4 different benchmarks that are being ran, actually 8, so 4 on the bare metal, and then 4 on the virtual machine. The only one that is not a comparison is the first one, the SAP HANA hardware and cloud measurement tool. That's basically storage testing. They have some tests included, that not covering storage, but mainly it's a storage, and you have to hit absolute markers here. Second would be the SAP HANA performance barrier tests. They include a set of abstract but adjustable queries that are thrown against the database, and that's the first one where we have to reach a close to bare metal results inside the virtual machine. I use the word abstract because the next two, OLTP, OLAP mixed workload simulations, and the SAP Business Warehouse Edition for SAP HANA Benchmark are simulations. So they stimulate end user they simulate queries that happen in a end user world. So you do not use a script to run queries against the database. You stimulate in a SAP application 10,000 users working at the same time, or 5,000 or 15,000, and these queries are hit against the database. Again, all three of them, all the three last of them, all have to be close to the bare metal performance inside the virtual machine. Okay. Chasing performance. I'm saying this in this detail because transporting the performance through the abstraction layer into the virtual machine is can be tough. With a, let's call it default virtual machine, you see you definitely have a problem with latency. Even when you do some tuning, you have some problems with latency. CPU latency was one of the problems that we had. Let me explain the sentence: unpredictable latency variances with activated boosters. So what I mean with boosters here is everything that changes the behavior of a CPU on CPU level, like C-states. If a CPU idles, it changes the C-state, and there's a time gap between changing these states. Just an example. And when running in a virtual machine, we've seen that there were unpredictable latency variances when things like these were activated. Some make absolute sense, by the way, but however, turning the CPU just on is a good way to start when you want near bare metal latency here. Network latency, storage latency, I will get into that soon. Storage itself is a second bullet point because we also face challenges with the throughput here. Just an example, something like worst case. So this is, let's look at the first one only. The first two bars show the average latency of a copy job inside the virtual machine, a payload of 16 gigabytes with a block size of 64 megabytes, to a direct attached device, in that case an NVMe, that has been attached through the virt.io library. The second two, so this is write and overwrite. Second two is the same NVMe attached on the PCI bus using the virtual function IO library. And the third one is bare metal performance on the same devices, on the same system, without the abstraction layer. I'm not saying this is a problem. This is one of, I don't know, 1,000 results that we have to compare. This is one of them. There are actually results that we see where the application benefits from the virtualization when it comes to performance, which then covers that one up. Chasing performance. CPU pinning. So when some of you probably know your way around in the virtualization. With virtualization, what virtualization does basically is it gives you the flexibility, all the flexibility. In the best case, and if you don't know anything about the underlying infrastructure, you just click create virtual machine. It creates some virtual machine, and the virtual machine works, and you are fine. You don't want to know where exactly does the virtual machine run. You don't want to know what CPU cores are used. This is all something that you do not need to know unless you start to think about performance. And it makes absolute sense. I mean, if the virtual machine runs on the fourth socket on a four-socket system but uses the cores of the first socket and the memory of the second socket, the length of the data stream is longer than if you do this. A virtual machine is NUMA aware. So, especially on a multi-socket system, you try to clone the NUMA topology of the physical system to the virtual machine. And then you pin every virtual CPU core that is presented to the guest operating system to a real physical core or its hyperthread, so that the actual physical topology is being presented to the virtual machine, making sure that the length the data has to travel from the operating system to the CPU is as short as possible. This gives a significant performance boost. At the same time, the memory is always the same principle, actually. If you run a virtual machine on a certain socket, you want the virtual machine to use the memory attached to that socket and not a socket that is away from the physical CPU that you use. All to minimize the latency on that level. Sorry. No sharing, no balancing. So everything is dedicated to the VM. If you use 28 cores of your CPU, of your physical CPU, those cores that are pinned to the virtual machine are then dedicated to that virtual machine. There are exceptions on CPU level. There are no exceptions on memory level. If you want your virtual machine to be most performant, you dedicate the memory to the virtual machine as close to the virtual machine as possible. A subset of all the configuration we do when it comes to the hypervisor configuration. I just talked about the first two bullet points. Hyperthreading needs to be enabled. vCPU pinning needs to be enabled and configured for all used virtual CPU cores or all used physical cores respectively. The virtual machine needs to be NUMA aware, not only NUMA aware, but needs to clone the physical NUMA topology one-to-one. I don't want to go into the virtualization specific tricks. We have some tuning parameters that are covered in this section. It's all in the best practices guide that I will talk about soon. At the current point in time, we dedicate about 91.75% of the physical available memory to the VMs. So this is from a time where we only had single VMs. Single VMs scenario, think that there would be an S attached. But 91.75% of the memory is used for the virtual machines. The memory is backed with huge pages with the size of 1 gigabyte. And when it comes to I/O, we use SRIOV for networking and NFS storage, and PCIe pass-through for fiber channel storage and direct attached storage. I just said it. All that I just have bored you with is in this very cool lecture available under this address. You find all the information you basically need there. So all the supported scenarios are in there. Considerations about sizing, detailed configuration guidelines for hypervisor, virtual machine, and guest operating system, and some performance considerations. A short example to that. The next version of that guide will contain what I just talked about, the virtual CPU pinning. I would like to include a short section explaining what happens if you do not use virtual CPU pinning. There are upsides and downsides to that, but so that you have, or that everybody has, the possibility to make a better decision on that topic. Okay, roadmap and outlook.
So you see that he can talk for hours about this stuff. He really knows this shit. So let's talk about what's coming up.
By the way, if you have questions about what I just talked about, I'll be here until Wednesday. You find me at the booth, and let's meet if you want to discuss this. Roadmap and outlook. This is how it looks like currently. We have validated single VM scenarios on the Skylake CPU architecture, and we have validated single VM scenarios and multi-VM scenarios on Cascade Lake, on the Cascade Lake CPU architecture. This is Outlook. For the Sapphire Rapids CPU architecture, we are aiming at single VM scenarios, multi-VM scenarios, both scale up only, and live migration as a stretch goal. Stretch goal because there are obstacles that I have a personal interest in eliminating until the validation is done. But
if I let him, he will do it.
I don't want to put it here, and then there is one obstacle that I miss, and then I told you now today there will be live migration, and there's not, so I'm putting this as a stretch goal. In numbers, this means on the Skylake CPU architecture, we have validated up to 4 CPU sockets and up to 3 terabytes of memory. On the Cascade Lake CPU architecture, we have validated up to 4 sockets and 6 terabytes of memory. And on the Sapphire Rapids CPU architecture, on that note, yes, we have skipped Ice Lake and Cooper Lake. We are aiming at 2 CPU sockets with 4 terabyte RAM, 4 CPU sockets with 8 terabyte RAM, and 8 CPU sockets with 16 terabytes of RAM. This looks different to that because until the Cascade Lake, calling it time frame, we could do a up to kind of validation. So we validated 4 sockets with 6 terabytes of memory, and everything underneath was covered. In the Sapphire Rapids time frame, we need to do a staged approach. So we are currently validating, well, the 2 and the 4 socket validation are kind of running simultaneously, but on the document, the date of the 2 socket validation will be earlier than the 4 socket validation. Afterwards, we will do the 8-socket validation. I should add, this all contains forward-looking statements subject to change without notice. The scope of the current validation, we are aiming at validating /15 SP5. One word about that, because we're talking about it for the last half an hour. This is a hypervisor validation. This is not a statement about the guest operating system. Inside the VM, you can use whatever operating system is validated against SAP, even others, possibly, but you don't want to do that. This statement is, so again, jokes aside, this statement is about the hypervisor. The hypervisor has to be /15 SP5. Once the validation is done, what you do inside the VM is subject to other SAP nodes and other validations and certifications. As already said, we are aiming at Sapphire Rapids CPU architecture with servers with up to 2, 4, and 8 sockets, with up to approximately 4, 8, and 60 terabytes of RAM for the VMs. So not every VM has to have that much memory. All VMs combined in a multi-VM scenario will have up to 4, 8, or 16 terabytes of memory. We want to validate, again, all 3 storage types, NFS, Fiber Channel, and Direct Attached. And we are, as already said, aiming at the validation scenarios, single VM and multi-VM, and my personal favorite, live migration. And with that, I'm 3 minutes early.
So,
feedback and QA.
As you can see, this stuff is pretty complex, and it involves a whole lot of testing. Those benchmarks and tests and comparison between bare metal and virtual, this is not only done once. You have to get there to reach the KPI. So we do benchmark after benchmark after benchmark. The last validation took us a bit more than 9 months, I think. That's also why it's SP5 and not SP6, because we started when SP6 was not available. And it's really, really complex. So I would invite you to ask your questions. And also, if we have any feedback, that would be great. If you come up with a question later that's not related to the session, you might want to visit all the other SAP-related sessions that we have here, or visit us at the booth. So they always know where we two are if you have a question. I would be really happy to talk to you about all of this. So thanks a whole lot for being here.
Thank you.